Caroline, and you will be hearing from Ben, Omar, and Brianna, and we are the Go-Go Guys. We are presenting on a range of motion measurement device that is used by physical therapists to track patient recovery progress after joint injury or surgery. The current device for this range of motion measurement is a goniometer. Here's a video of a physical therapist using this goniometer to measure both flexion and extension of a knee joint. Feedback from physical therapists revealed this device was very hard to read, and those ballpark readings led to very inaccurate measurements. Additionally, different size goniometers are needed for different joint sizes, with smaller goniometers being used on joints like the wrist and larger goniometers being used on joints like the knee. Physical therapists had to buy a lot of different goniometers, which is inconvenient as they all have the same standard design and function. To address these concerns, we came up with 3 design inputs: adjustable to different dimensions, readable against any background, and reproducible, meaning different physical therapists would be able to obtain the same measurement. With these 3 design inputs in mind, we came up with our business thesis. Physical therapists will use a reproducible, repeatable range of motion measurement device in order to track flexion and extension progress over a patient's recovery period. This device will take universal measurements across a variety of joints and patient sizes, removing the need for joint-specific devices, and it will have increased accuracy and precision compared to current market devices. Our final design is unique, as it has adjustable arms, an opaque background for easier reading of measurements, and it comes with specific instructions for use. This innovative solution will excite physical therapists around the world, as they finally have one device they can trust for all of their range of motion measurement needs.
Our solution was to create an extendable arm that can be adjusted. Our first design split the stationary arm into 2 6 by 1 inch rectangles. One arm would have a slit running alongside the middle, parallel to the 6-inch side. The other arm would have a hole at the 0.5 inch mark for a screw to fasten the 2 arms together, allowing for movement along the slit. An issue we had was the extending arm would rotate and cause difficulty handling. We solved this problem by attaching a guide rail to the bottom arm to prevent rotating. Another solution we tested was to remove the guide rails and use 2 holes for the extending arm. The 2 holes stopped most of the rotation but did not eliminate all the rotation compared to the guide rail. To tackle readability, we used a foam core cutout of the circular part of the goniometer and attached it under where the numbers are read. This idea improved readability as it gave an opaque background to the numbers, allowing for anyone to read it clearly. These ideas to improve the goniometer helped pave the path for us to create the final design.
Our final design is composed of 2 measurement arms, one stationary and one moving. Each arm is adjustable from 6 to 11.5 inches in order to account for different joint sizes. This means not only can the device be used for different joints, but it can be adjusted to fit the size of the person. Additionally, our device is easier to read as there is a solid background behind the degree measurements. Here you can see the device. You adjust the arm by pressing down on the spring and simply sliding the extension to the next opening, similar to the way a crutch is extended. Here you can see how our design is more easily readable. The degrees have an opaque background, allowing the black degree numbers to pop out more. The moving arm is transparent with a solid line that points to the degree of interest. An instructional pamphlet will also be sent with each device. The instructional pamphlet will not only explain the unique aspects of our designs and their function, but will also set a standard process for measuring range of motion. After finishing our final design, we contacted 2 physical therapists to receive feedback on our improved goniometer. They said that they really liked the opaque degree background as it is much more readable. They said with the existing goniometer they have a very hard time reading the degrees against certain patterns, and this would solve that issue. They also really liked the adjustable arms and how it makes it applicable to multiple joints, as this eliminates the need for multiple goniometers. Then we ran testing on the extendable arms to determine the force that they could withstand at each increment before fracture. At its weakest point, the arm is fully extended and can withstand 14 newtons, which is similar to the force required to crack a neck.
With over 700,000 physical therapists in the US and the European Union, we believe that there is a large market for this device. Each physical therapist has at least one of these devices in their location. Our device will cost about $4 to make, and we believe that we can sell it for $15 since it encompasses more than one device. Therefore, the service available market is $10.5 million given by the $15 cost and the 700,000 physical therapists. Our service obtainable market is about $525,000 since we believe that we can capture about 5% of this service available market in our first 2 to 3 years of business. Moving into our FDA classification, our device will be classified as Class 1 since it is non-life sustaining and there is no risk to patients. Like the other 95% of Class 1 devices, we will not have to go through pre-market approval. We do have to ensure our quality through practicing good manufacturing practices and through good labeling. We will have to go through establishment registration with the FDA, and the timeline to complete this is about 1 week. Then the device will be listed with the FDA and we can take it to market.
Once again, we are the Go-Go Guys, and we thank you for your time.